Ever pondered why understanding rocks and soil matters in our daily life? Let's dive into this fascinating world beneath our feet. Rocks and soil are more than just the ground we walk on. They play a crucial role in our everyday lives, often in ways we might not even realize. From the homes we live in to the food we eat, rocks and soil are instrumental. Take construction for instance. Rocks, in their various forms, are the bedrock of our infrastructure. Granite, a type of igneous rock, is widely used in construction due to its durability and resistance to weathering. It's the reason why our buildings and monuments can stand tall for centuries. Similarly, limestone, a sedimentary rock, is a key component in cement, which, as we know, is essential in constructing anything from a small house to a towering skyscraper. Now let's talk about farming. Soil, the upper layer of earth in which plants grow, is a complex mixture of minerals, organic matter, gases, liquids, and countless organisms. It's the lifeblood of our agriculture system. The type of soil in an area can greatly influence what crops can be grown there. For example, clay soils, known for their water-retaining properties, are ideal for crops like rice that require a lot of water. On the other hand, sandy soils, which drain water quickly, are perfect for plants like cacti and succulents that need less water. Beyond construction and farming, rocks and soil also play a significant role in maintaining environmental health. They help filter our water, absorb carbon dioxide, and they even provide habitats for a myriad of creatures. But remember, not all rocks and soils are the same. They have unique properties and uses, and understanding these can help us make better decisions in construction, farming, and environmental conservation. We are surrounded by a world of rocks and soil, each with their unique characteristics. Understanding them better can help us appreciate and utilize them more effectively. So next time you step outside, take a moment to appreciate the ground beneath your feet. It's more important than you might think. Rocks, they're not all the same. There are three main types: igneous, sedimentary, and metamorphic. Each rock type has a unique story to tell about the Earth's past, and each plays a critical role in our world today. Let's start with igneous rocks. The term igneous comes from the Latin word ignis, which means fire. These rocks are formed when magma or molten rock cools down and solidifies. If this happens beneath the Earth's surface, we get intrusive igneous rocks like granite, a common countertop material. On the other hand, if the magma erupts from a volcano and cools on the Earth's surface, it forms extrusive igneous rocks. Ever heard of basalt? That's an extrusive igneous rock, and you'll find it in the oceanic crust. Next up, we have sedimentary rocks. These are the storytellers of the rock world. They are formed from the accumulation of sediments. Think sand, silt, and even remains of plants and animals. Over time, these sediments are compacted and cemented together to form rocks. Sandstone and limestone are common examples. Fossils are often found in sedimentary rocks, giving us a glimpse into the Earth's history. Last but not least, let's talk about metamorphic rocks. The term metamorphic comes from the Greek word metamorphosis, which means to change form. These rocks originate as igneous or sedimentary rocks, but then undergo a transformation. They are subjected to intense heat and pressure within the Earth's crust, altering their physical and chemical properties. The result? New rocks like marble, which starts its life as limestone, and slate, which begins as clay. Now you might be wondering, how do these rock types connect? Well, that's where the rock cycle comes in. Imagine it like a never-ending conveyor belt of rocks. Igneous rocks can weather and erode into sediments, which then form sedimentary rocks. Sedimentary rocks can be buried and subjected to heat and pressure, transforming into metamorphic rocks. And if metamorphic rocks are melted, they form magma, which can cool to become igneous rocks. It's a continuous dynamic process that shapes our landscapes and provides us with valuable resources. From the fiery birth of igneous rocks to the transformative pressures that create metamorphic rocks, the world of rocks is a fascinating cycle of creation, destruction, and transformation. Just as rocks come in different types, so do soils. Let's dive into the world beneath our feet. Soil, it's everywhere. Under our feet, in our gardens, and it's more than just dirt. It's a complex mix of minerals, organic matter, water, and air. There are 6 main types of soil we're going to discuss today: sandy, clay, silt, peat, chalk, and loamy. Each of these has unique characteristics and uses. Let's start with sandy soil. This soil feels gritty to the touch, drains water quickly, and is easy to work with. However, it's not the best at holding on to nutrients or water, which can make it a challenge for gardeners. You'll often find sandy soil in coastal regions and along riverbanks. Next up is clay soil. It's the polar opposite of sandy soil. It feels smooth and sticky when wet, and it's excellent at holding on to water and nutrients. But this can also be its downfall, as it can become easily compacted and drain poorly, making it hard for plant roots to grow. Clay soil is commonly found in low-lying areas. Third on our list is silt soil. It's a fine-grained soil that feels smooth and flowery. It holds water longer than sandy soil but drains better than clay. It's fertile and good for growing crops. You'll find silt soil along river deltas. Now let's talk about peat soil. It's a dark, nutrient-rich soil that holds onto water well. However, it's slightly acidic and can take a long time to warm up in the spring. Peat soil is often found in boggy, waterlogged areas. Fifth is chalk soil. This soil is typically alkaline, which can affect the types of plants that can grow in it. It drains well, but can be hard to work with when it's dry. You'll often find chalk soil in areas with underlying chalk or limestone bedrock. Last, but certainly not least, is loamy soil. This is the gold standard of soils, often considered the ideal gardening soil. It's a well-balanced mix of sand, silt, and clay, making it fertile and easy to work with. It drains well, holds onto nutrients, and warms up quickly in the spring. You can find loamy soil in many places, but it's most common in river valleys and flat, open areas. Soil, the skin of the earth, is a complex mix that supports life. Understanding its types helps us make better use of this precious resource. So next time you're digging in the garden or walking in the park, take a moment to appreciate the soil beneath your feet. It's more than just dirt. It's the foundation of life as we know it. How do chemical fertilizers affect the soil that feeds us? Well, picture this. You're a farmer and you want your crops to grow faster, bigger, and better. You turn to chemical fertilizers, which can seem like magic potions promising a bountiful harvest. But let's dig a bit deeper and see what's really happening beneath the surface. Chemical fertilizers are developed to provide the nutrients plants need most: nitrogen, phosphorus, and potassium. They are like a fast food meal for plants, quick, accessible, and easy to consume. But just as too much fast food can harm our bodies, over-reliance on these fertilizers can have negative effects on our soils and farms. Let's start with the soil. Overuse of chemical fertilizers can lead to nutrient imbalance in the soil. While nitrogen, phosphorus, and potassium are essential for plant growth, they are just 3 of the many nutrients plants need. Over time, the excessive use of these fertilizers can deplete other essential nutrients in the soil, leading to an unhealthy, imbalanced ecosystem. Beyond the soil, the impact of chemical fertilizers extends to our water systems. When it rains, these fertilizers can leach into our groundwater or run off into nearby rivers and streams. This can lead to a phenomenon known as eutrophication, where an overabundance of nutrients in water bodies causes excessive growth of algae and other aquatic plants. This can disrupt aquatic ecosystems and even lead to the death of fish and other marine life. And let's not forget about the greenhouse gas emissions. The production and application of chemical fertilizers are significant sources of greenhouse gases contributing to climate change. So while chemical fertilizers can boost crop growth, they are not a one-size-fits-all solution. Their overuse can lead to nutrient imbalances in the soil, water pollution, and even contribute to global warming. However, this doesn't mean we should completely abandon their use. Rather, responsible use, combined with other sustainable farming practices, is key to maintaining the health of our soils, our environment, and ultimately, our own health. While chemical fertilizers can boost crop growth, their overuse can have unintended consequences. Responsible use is key to sustainable farming. From the mountains to the food we eat, rocks and soil play a fundamental role in our lives. As we journey through this intricate world beneath our feet, we've delved into the fascinating realms of rocks and soils and their significant impacts on our everyday life. We started off by understanding the types of rocks. Remember, rocks are not just stones. They are intricate structures with a story to tell. There are 3 main types: igneous, sedimentary, and metamorphic, each formed through unique processes and each possessing distinctive characteristics and uses. From the igneous rocks that form from cooled magma or lava, to the sedimentary rocks that take shape from the accumulation of sediments, and the metamorphic rocks that are the result of intense heat and pressure altering other rocks, we've seen that our world is built on an ever-changing foundation. We then explored the world of soils. It's more than just the dirt we walk on. It's a complex system that supports life as we know it. We've learned about the different types of soil, sandy, silty, clay, peaty, chalky, and loamy. Each type of soil has its own composition, texture, and characteristics, which makes it suitable for different types of vegetation and wildlife. Finally, we took a look at the impact of chemical fertilizers on our farms and farmers. We learned how these fertilizers, while boosting crop yield, can have detrimental effects on the soil's health, the environment, and even the farmers themselves. It's vital to understand these impacts to make informed decisions about our farming practices. So, as we wrap up, let's remember that the ground beneath us is not just dirt. It's a complex world, constantly changing and evolving. It's the bedrock of our civilization, the foundation of our food chain, and a testament to the dynamic nature of our planet. The next time you step outside, remember that the ground beneath your feet is more than just dirt. It's a fascinating world of rocks and soils, full of stories and secrets waiting to be discovered.